Hello, welcome to the machine learning at home. Today I will speak about how to clusterize the mixed data. Mixed data is a data which consists not only of numbers, but also of categorical variables and maybe something else. First of all, we must create this data, and I will make it artificially from the well-known iris data. So, for example, I will create character name with iris pw, and that will be actually column number 3. So I will cut the column of iris petal width. It's actually column number 4 in 3 intervals. So what will happen? Column number 4 petal width consists of numbers, and we split them into 3 intervals. And then, to make sure that we did exactly what we wanted, we can check the structure of this data. You see, this is a factor of 3 levels. Actually, factors are categorical variables represented numerically. And then I will create some new iris data. I will call it exactly like I said, iris new. And this iris new will consist of iris data of first 3 columns and our new iris dot pw uppercase. So I will use cbind. Cbind from iris data, which is the same as original iris, but I will remove columns 4 and also 5, column which contains species names. We do not need it. So remember to put parentheses after minus, otherwise this will not work. And then I will add here our new iris dot pw. Okay. And something is wrong. Oh yes, of course. Double square bracket. Looks like now everything will be good. Yes. And then I will check the structure of this new data, just to make absolutely sure that we have exactly what we wanted. Yes, you see, we have 3 original columns, which consist of numbers, and column number 4 consists of factor, with 3 factor levels. This is what I want. And I will use library keymet. So library keymet. It's a very nice library which consists multiple distant measures for mixed data. There is a very famous gather distance which will take into account mixed data of that sort. But there are many more of them, and I will use 2 as example of how to work with clusterizing mixed data. So first of all, I will use Wishart distance. This is a form of distance which will be calculated from multiple different sorts of variables. And I will use function distmix. So distmix is a function which supposedly work with the mixed data. So distmix will need a name of data set, iris new. And we need to specify a method, which is Wishart. And also we need to specify which columns are which. So numerical columns are columns number 1, 2, and 3. You can see them. So id num is equal to 1 to 3. And then id categorical, id cat, is equal to column number 4, which is our new data iris dot pw. And of course, everything which is calculated, I should write in some new object. So for example, iris dw. And this looks like correct. Okay, nothing outputted, then everything went well. And next step will be to make clusters. So for clusters, the package keymet contains specific method fastKeymet. So a method which is used keymedoids. So this is a method based on medians. Kind of robust, interesting method, and we can try it. So we can use this distance, by the way, for different purposes. So you can use this package, for example, to calculate many mixed distances and then use it for different ways of clusterizing. Or we can use method which is already installed within a package. So I will use the second approach, iris. I will use new object, dw key m, I will call it. And then fast key m is a method, key met. Okay, and then I will use my iris dw distance, vshart distance, originated from my mixed data, and then I will try to specify number of clusters. It's actually all methods which are doing this type of clusterizing will need numbers of clusters. Well, and now what I will do? Well, I need somehow evaluate my results. And I typically use my own library, Shipunov, and will try to use misclassification table or confusion matrix which is installed in this package, which can a function misclass uppercase can do it for very unusual cases like this one, because clusters have numbers whereas species have names and they not necessarily correspond. So most of confusion matrices methods will not count for that and will give you unreliable results. A misclass can do reliable results. So we need only to compare iris dw km, it's our object, and it should contain cluster object, and then I will compare it with iris species. That was column number 5, which we omitted in our new data. And then I must specify best equal to true, otherwise results will be not reliable. Okay, let us see what's going on. Okay, well, actually misclassification error for typical key means based on iris data, unmodified, not our modified, unmodified, original data, is about 10%. So it's not bad, because we lose information. When we split our variable in 3 intervals, we definitely lose plenty of information. So even with less information, we're still able to achieve misclassification error of 12%. No, so 13% we can say. And let us try some different method of working with mixed data. For example, Huang method is installed also, and we can use that Huang method instead of vshart. So simply replace with Huang, and then we'll change the name of resulting data, dh it will be. Okay, everything else is the same. And now we used same fast key met method, but with now new object. Again, change into h, change into h. Okay, and now we can use same misclassification table confusion matrix, but for new type of data, dh, new type of clusterization. Oh wow, this is even better than normal way of key means. So 5.3%. So splitting one of variables into 3 groups, into 3 intervals, will even increase the power of clustering. So 5.3%. Very interesting. Actually, iris data is a bit unusual. It's very well stratified, so maybe that's why. Anyway, so this, as you see, mixed data can do wonders, at least sometimes. And if you know how to use a package for missing data, this key met, you can win. You can make very nice results out of data which normally considered as not easy data at all to work with. So again, today we learned how to work with mixed data which consists in our case of numbers and also of categorical variables. Thank you very much.